All right, let's dive right in. Today, we're going to explore a truly mind-bending idea, a journey into the hidden world inside our own heads. What if the basic building block of thought, the neuron, is infinitely more complex than we ever imagined?
This is really where the story begins, with this sense of pure shock. It's that feeling you get when you realize you might be on the verge of a completely new way of seeing the world, or in this case, a new way of seeing ourselves. And this is the question that changes everything. We've all been taught to think of the brain as this incredible biological computer, right? Just a bunch of on-off switches firing away. But what if that metaphor is totally wrong? What if it's less like a computer and a lot more like music? To even begin to wrap our heads around this, we have to start with the sheer scale of what's going on inside just one neuron. I'm telling you, the numbers we're about to see are enough to completely shatter that old, simple on-off model. Okay, so inside a single one of your neurons, you might have about 100,000 of these tiny, tiny structures called microtubules. You can think of them as the internal scaffolding, the very architecture that gives the cell its shape. And here's where it just gets wild. The research we're looking at suggests that every single one of those 100,000 microtubules could be vibrating millions of times per second. I mean, we're not talking about a gentle hum here. This is an orchestra of unimaginable speed and scale playing inside every single thought. And if that's true, well, it changes everything. It means cognition isn't just about electrical signals zipping down a wire. It's about resonance. It's about the very structure of our cells. Well, singing. The structure itself is the music. So let's look closer. What exactly is this internal architecture? And how does it force us to completely rethink the neuron, our basic unit of thought? So, microtubules, they aren't some weird speculative sci-fi thing. Nope, they are a well-known part of cell biology. Just picture these tiny, hollow tubes built from proteins, all arranged in this incredibly precise, almost crystal-like pattern. And look, in mainstream science, we already know they're absolutely critical. They're the skeleton of the cell, they're the highway system that moves vital cargo around. They even guide how neurons grow and form stable connections. They are, without a doubt, essential. This slide just frames the whole conceptual jump perfectly. We have to go from thinking of a neuron as a simple wire to seeing it as this bustling, complex metropolis. The inside is an empty space. It's a dense city. And it's not a simple switch. It's this dynamic, constantly humming, vibrating structure. And that brings us to the next really crucial layer of this whole idea, a symphony of different speeds. See, these vibrations are happening on a timescale that is just ridiculously faster than the brain activity we usually measure. It suggests there's this whole hierarchy of time operating at once. And this does a great job of showing what that means. Way down at the fastest level, you've got molecules doing their thing in nanoseconds. A step up, you have these microtubule vibrations in microseconds. Then you get to the stuff we all know about, the neural spikes firing in milliseconds. And all the way at the top, you have the big brain rhythms that shape our thoughts unfolding over seconds. It's all happening simultaneously. The source material uses this really beautiful music analogy to tie it all together. Think of it like this. The fastest vibrations are like the tiny microtones between notes. The familiar neural spikes are the individual notes. When groups of neurons fire together, you get chords. Those chords build into the melody of our brain rhythms. And maybe, just maybe, conscious experience itself is the final symphony that emerges when all of it plays together in perfect harmony. So, all of this leads us into some of the most fascinating, and let's be honest, most controversial ideas about the brain. We're really heading out to the frontiers of science here. This is the famous ORC-OR theory. It was put forward by Nobel Prize-winning physicist Sir Roger Penrose and an anesthesiologist named Stuart Hameroff. And it is a bold idea. It suggests that these microtubules are literally the stage where quantum mechanics happens in the brain, giving rise to consciousness itself. So the theory basically has three big claims. First, that the little proteins that make up the microtubules can exist in multiple states at once. That's quantum superposition. Think of it like a coin spinning in the air, being both heads and tails at the same time. Second, the microtubule structure helps all these spinning coins link up into one big, coherent quantum wave. And third, and this is the big one, the moment that wave collapses into a single definite state, that is a moment of conscious experience.
Okay, but it is super important to be clear about this. As cool as this idea is, the orco theory is still very much on the fringes. It is highly speculative. Most neuroscientists do not accept it and believe we can explain consciousness without needing to bring quantum physics into it.
But here's the thing. Whether you buy into the quantum part of the theory or not, this underlying idea of coherence, of all these different parts working together in harmony across all these different scales, that is an incredibly powerful way to think about how consciousness might actually work. And that brings us right back to where we started, to that core shift in how we think about this stuff. If we let go of the idea that the brain is just a machine running code, what are we left with? We're left with this. The idea that consciousness isn't a thing you can find somewhere in the brain. It's an emergent property. It's what happens when all those synchronized oscillations, from the tiniest and fastest to the largest and slowest, come together in this act of coordinated, artistic coherence.
This chart is a pretty cool way to visualize that new framework. Yeah, computation is important. That's the first bar. But this theory suggests that the constant vibration, the oscillation of the brain's very structure, is even more essential. And then finally, the tallest bar represents coherence, the idea that consciousness itself is what emerges when all of those oscillations finally achieve a state of harmony.
The source puts it so beautifully here. A moment of consciousness isn't just a calculation being solved, it's something way more profound. It's that fleeting, incredible moment when the impossibly complex matter inside our heads just aligns. So, we'll leave you with this final question to ponder. What if consciousness isn't a place, or a thing, or a computer program, but it's simply that one exquisite moment when all the different instruments, from the fastest vibrations to the slowest brain waves, finally synchronize, and the entire orchestra becomes one?